before we start the lecture, let's have a recap of what we have covered in the previous session. In the previous session, we talked about highest in the summation of all the squared distances with respect to mean, where this value represents the mean value of our data, and we'll square all the differences for all the observations from I is equal to 1 to n, and we'll take the average of this, right? So it is the average of all the squared differences with respect to mean, and it is denoted by sigma square. Then we discussed about standard deviation, which is nothing but the under root of variance. Then we talked about the difference between standard deviation and variance, where variance represents the overall spread, or it gives us the idea of the overall distribution of our data, while standard deviation gives us the average dispersion per observation, right? Then we discussed about the quartiles. So quartiles helps us to divide our data into 4 equal parts, where quartile Q1 represents the 25th percentile of our data, which means 25% of our data will lie below this value. Q2 represents the median or the 50th percentile of our data, and Q3 represents the 75th percentile of our data. Then we discussed about the IQR, which is interquartile range, and it is calculated by taking the difference between Q3 and Q1, which represents this particular value, this particular 50% of our data. Then we discussed about what this range represents. This IQR range represents the internal or middle 50% of our data. And we can say that if this IQR is high, then our data is largely distributed. And if this value is low, then we can say our data is closely distributed. Now let's set the agenda for this session. In this session, we'll discuss what visualizations are. Then we'll discuss some of the advantages of using visualizations. Then we'll discuss the different types of data we can visualize. And finally, we'll move on to the different types of visualizations we can do on our data. So without further ado, let's start the session. First, let's understand what visualizations are. Visualizations are nothing but the visual representation of our data. So visual form of data. What visualizations do is it helps us to present our data in a way that is easy to understand and interpret. Now let's consider an example of an ice cream shop. Let's say I have 3 columns in my data, which is year and month and sales of the ice cream shop. Let's say year 1, month Jan, sales is 2000. Year 1, month is Feb, sales is 3000, and so on. Year 1, month is June, and sales is around 10,000. Now this data will look something like this. Looking at this raw data won't make any sense to me. I won't be able to easily understand any patterns in my data or any trends that my data is following. But if I plot a line chart with my data, it will give me some sort of line like this. Like this, where my x-axis represents the months from Jan to December. Somewhere in the middle there will be June, and this represents the sales of ice cream shop. Now if I just look at this graph, I'll be able to easily understand that during the summer months, the sales of ice cream is comparatively high, right? If we compare with Jan and December or remaining winter season months, we can easily say that during summers, the sales of ice cream is higher. Using this information, I can arrive at decisions like stocking extra ice cream during summer because the sales is comparatively higher. So obviously the demand will also be higher. This is how we can visualize the data and easily make insights out of it. Now let's understand what are the different advantages of using visualizations. First is the easy communication of data. So we already saw with this example, this graph here easily represents our data. And if we just directly look at the raw data, we won't be able to understand any patterns or trends in our data. So easy communication of data. Another advantage is understanding trends or patterns in data. Another great advantage that visualizations gives us is the outlier detection. Here, outlier represents an abnormal value which do not follow the general trend of our data distribution. So visualizations also helps us to understand these outlier values and to detect them. Now, let's discuss about the different types of data we can visualize. Mostly, data can be of two types, that is qualitative and quantitative. Qualitative data mostly represents the categorical type of data, which mostly consists of labels or categories. Now, categorical data can also be of two types, that is nominal and ordinal. Here, nominal data represents something that cannot be ordered, unordered data. Nominal data will represent unordered labels. Let's take an example for this. So, a good example for this nominal type of data could be favorite colors of students. Favorite colors of students in a class. If we take a survey of the favorite colors of students in a class, it will give us nominal type of data since there is no order to the color they can select. I can't say that red is above blue or blue is above green. This is why colors don't have any order, which will represent a nominal type of data. Now let's talk about ordinal data. Ordinal data, as the name suggests, it is something we can order. So ordered labels. A good example for this could be the satisfaction rating given by the customer. So they can rate like very satisfied or neutral or not satisfied. Now here I cannot say that very satisfied is equal to not satisfied. Both of these have different quantitative value with respect to the satisfaction level of customer. So as we go from not satisfied to very satisfied, the satisfaction level of customer actually increases. There is some quantitative value with respect to these labels, right? This is why this comes under ordinal data. Now let's talk about quantitative data. It mostly represents numeric type of data. And this is also divided into two subparts, that is discrete and continuous. Now discrete data is something that is countable, like the number of students in a class, number of students in a class, or number of cars in a parking lot. These are all examples of discrete data because these are things we can count. Now, continuous data represents any value in a range. Continuous data could have any value within a given range. For example, height or weight of students will give us continuous data. Now, let's take one example to understand discrete and continuous data better. Let's take an example of age. My current age is 25. Okay. So in terms of year, in terms of number of years, my age is 25, which will represent which type of data? This will be discrete data because number of years is something that I can count. So this will be discrete. But 25 may not be my actual age. Let's say I'm turning into 26 just 2 days after the current day. 2 days after today, I'll be turning 26. In this case, my age will be somewhere in between of 25 and 26, but not exactly 26 or 25, right? Hence, in this case, I can say my data can take any value within 25 and 26, which will represent continuous data, which will represent continuous data. So I can give value something like this because I'm turning it into 26 after 2 days. I can have 25.99 as my age, right? Between 25 and 26, there could be n number of ways to represent my current age, which will be continuous type of data. Now let's understand this data set. This data set shows us the specifications of different cars. Car specifications. So for every car, we have all these specifications listed down in a data set. We have body style, which tells us about which type of body does the car have. It could be convertible, hatchback, sedan, wagon, etc. All these are different categories of body style, right? Now, just try to guess what kind of data this body style will represent. If you have guessed categorical data, it is correct. Categorical or qualitative data. And to be precise, it will represent nominal data. Why? Because there is no order to the type of body a car can have, right? Now let's talk about fuel type. Fuel type also will be categorical type of data because there we have categories like gas, diesel, petrol, all these, right? And here also it will be nominal data because there is no order to the type of fuel. Then we have horsepower. Now, what kind of data does horsepower represent? Horsepower can take any value from a minimum and a maximum range, right? Hence, it will be continuous data. Price will also be continuous because I can have prices like 13,000, 0.5, 0.6, and what so on. There's no countable values to the amount of values I can have with respect to price. Hence, it will be continuous data. Continuous. Now, let's just quickly mark the remaining data types as well. We have combined MPG, which represents the mileage of the car, which will also be continuous type of data. Curve weight represents the combined weight of the car without any passengers. Can also be called as car weight. And this will also represent continuous data because it can have any value within a given range. Right? Finally, we have engine size, which will represent the size of the engine in terms of cubic inches. Now, this can also take any form. It could be 130, 130.5, right? Hence, it is continuous data. Now, let's talk about the different types of visualizations. Now, let's discuss about the different types of visualization. First up is the scatter plot. Scatter plot helps us to establish relationship between two continuous variables. So, helps us to establish relation between continuous variables. For example, if we want to understand the relationship between the height and the weight of a student, the scatter plot between height and weight, where height will be our x-axis and weight will be y-axis, we can easily identify the pattern if with the increase in height, the weight also increases. Now let's look at the graph given below. In this graph, we are plotting a scatter plot between horsepower and mileage of the cars. Now, if you see these data points represents the different cars we have in our data set. For each car, we took the horsepower and mileage as X and Y and we plotted the data points like this. Now, all these data points represents the overall trend or overall relationship of these two variables. We can see as we go further with the horsepower, as the horsepower increases, we can see the points are shifting towards lower side for mileage. This represents that our overall trend is going somewhat downwards, which depicts that these two has a negative relationship where the change in one of them will cause a negative change in the other. As we see here, with the increase in horsepower, the mileage of car actually reduces. Now let's look at one more example for scatter plot. Here we are plotting the scatter plot between horsepower and price. Now if you see, the data points here are shifting towards the higher side. So as we go from left to right of horsepower, we can see that the price of cars also increases. Now this here represents a positive relationship between these two, where the change in one of them will cause a positive change in the other one. Now let's discuss about line plot. Line plot also works in the same way as the scatter plot does. The only thing is all the data points that we have plotted on our graph will join them with a line. So as we see here, this line joins all the data points we saw for horsepower and mileage in the scatter plot, and by joining those points it will be very clear how our relationship is going from left to right. We can see that this line shows us as we go from left to right, as we increase the horsepower of the car, the mileage of cars reduces. It makes this much more clear than what we saw with scatter plot. So what line plot does is it helps us to plot the trends. Now mostly we'll be plotting trends with respect to time, but in this case we are plotting a line plot between horsepower and mileage, which is giving us the sense how these two variables affect each other. Now let's look at the line plot between horsepower and price. Here also we can see the line is going upwards, or it's moving upwards as we go from left to right. This represents a positive relationship between horsepower and price of the car. Now let's discuss about bar plots. Bar plots helps us to understand the relationship between continuous and categorical variables. Continuous and categorical variables. Here we have given a bar plot between body type and mileage of the car. In the x-axis we have body types. These are different categories of body type we have in our dataset: convertible, hatchback, sedan, wagon, and hardtop. And in the y-axis we have the mileage of the cars. What these bars represents is the average mileage for the given body type. For convertible, we can see the average mileage is somewhere around here, while hatchback has the highest average mileage. So what kind of information we can derive here? We can see that hatchback comparatively has the highest average mileage. So if a body type is hatchback, then we can say that in general they will have higher mileage compared to any other body type. Now let's look at one more bar graph. This bar graph depicts the relationship between body type and the price. Now these bar represents the average price for a given body type. So we can see the average price of convertible and hardtop is comparatively higher than any other body type in our dataset, right? So we can say the cars which have convertible and hardtop body type will have in general a higher price as well. So combining these two graphs, what kind of information we can derive? We can say that hatchback has the highest average mileage, and also they are cheaper than any other body type. Now let's look at one more bar graph. This represents a horizontal bar graph. Horizontal bar. Now, why do we need a horizontal bar graph here? Now, if you look here, we only had 5 categories in body type. But if I had 10, 15, or 20 categories, it will be very hard for me to understand this data because this x-axis will get a lot of clutter with the categories. So if the categories are too much in our data, what we can do is we can plot a horizontal bar graph, which will plot all the categories in the y-axis and the continuous variable on the x-axis. Here we have the relationship between the name of the company. So these are companies, and we have the price of cars in the x-axis, and these bar represents the average price of cars for the given company. So we can say that Jaguar has the highest average price compared to any other company in our dataset. While if we look here, Chevrolet has the lowest average price. So the cars from this company are the cheapest. And cars from Jaguar are most expensive. So this is how we can represent a relationship between continuous variables and the categorical variables using bar plots. Now let's understand the pie chart. Pie chart represents the distribution of data with respect to categories. So here, fuel type is a categorical variable, and this pie chart represents the distribution of cars for different fuel types. We only have two fuel types in our data, which is gas and diesel, and we can see that 90% of our cars runs on gas because the share of the pie is comparatively very high for gas. So in our data, most of the cars runs on gas, while very few, around 9.7% cars runs on diesels. This is how we can plot a pie chart to understand the relationship or to understand the distribution of our data with respect to different categories. Now let's look at one more pie chart. This pie chart represents the distribution of cars with respect to body type. So we can see that sedan is the most common body type in our dataset, where 46% of our cars, 46% of our cars are of sedan body type. While we also have 34% of the cars which are hatchback, followed by 12% of wagon, and we can see only a few percent of cars are actually convertible or hardtop type. This way, we can understand how different categories affect our data distribution. Now, let's talk about the count plot. Count plot helps us to plot the counts per category. So, for all the observations, which in our case is all the cars, count plot tells us about the distribution of cars based on the categories. In this case, fuel type is the category, and we can see more than 175 cars are having fuel type as gas, while remaining around 20 or 22 cars have fuel type as diesel. Count plot shows us the actual counts of a given category across the dataset. Now let's have a look at one more count plot. Here, our categorical column is the body type, and count plot shows us the different counts. These all bars represent the different counts for these categories. Here, count is the number of cars per category. So we can see that most of our cars are sedan, and the second most common car is the hatchback, followed by wagon, hardtop, and convertible. It's the same information that we also saw with pie chart, but pie chart shows us the actual distribution of different categories, while Count plot helps us to understand the overall count of these categories. Now let's talk about box plot. Box plot helps us to plot two things. First is the IQR, which is this box represented here. This box represents our IQR, which is the interquartile range, and this line are the whiskers. Now let's understand the box plot. So the major purpose of using a box plot is to understand the distribution of our data, distribution, and also to detect outliers. Now, if you see in this box plot, this range represents our IQR, where the edge of this box represents Q1, this edge represents Q3, and the middle line represents Q2, which is our median, right? This line represents the lower whisker for our box plot, and it is calculated as Q1 minus 1.5 into IQR. IQR, which is Q3 minus Q1. Right? So this sort of gives us a minimum value for our given. This is the upper whisker, and it is calculated as Q3 plus 1.5 into IQR. Now, if you see, this anyways will have 25% of our data, right? From Q2 to Q3. Also, this range will have Q1 to Q2 will have 25% of our data. So we can see 50% of our data falls within this range itself, from here to here, which is around 6,000 to 17,000. This is how we can understand how our data is distributed across different values of price. We can also see these data points. These are data points which do not fall within the whiskers or the interquartile range of our data. These are called outliers. Now, outliers are values which do not follow the normal trend or normal distribution of our data. See, most of our cars have a price range of this. Some of them exceed this range, some of them also are below this range. But most of our data is covered till the upper whisker. Lower whisker cover all the remaining 25% of our cars. But these few cars do not fall within the given range from upper whisker to lower whisker. Hence, these are considered to be outliers which do not follow the general distribution of our data. Now let's look at one more box plot, which is of horsepower. Now this one is a horizontal box plot, which makes it much more easier to interpret and understand. This again will be Q1, this will be Q3, and this line represents Q2, which is our median. Here also we can see some outliers are there, where there are four cars which do not fall within the upper and lower whisker of our box plot. These can be considered as the outliers. Now let's look at the box plot with multiple categories. Here, body style is in the x-axis, and in y-axis we have the price. We want to understand how the data is distributed for all these categories of body style, which is convertible, hatchback, sedan, wagon, and hardtop, and also compare them with each other. For that, we have used the box plot. Here we can see that convertible and hardtop have the highest medians, right? Median value is highest for these two categories. So we can say that hardtop and convertible generally have higher prices compared to other categories. Also, we can see the distribution, how the prices are distributed across these categories. For convertible, we can see that this range represents 25% of the data. This will also represent 25%, and remaining this range will cover the remaining 25% of our data. This will also have 25%. If there were some points that were outside this range, like this, those will be our outliers, right? As we can see here, for hatchback, there is one outlier which do not follow or do not fall within this range from lower to upper whisker. Similarly, for sedan, we can see a few outliers which do not fall within this range. Same with wagon, we can see one outliers there, and for hardtop, we don't have any outliers. So here's how we can compare and also understand the distribution of our data with respect to a continuous variable across all the categories for a given categorical column. Let's have a small comparison between box plots and bar plots. Here, this bar plot represents the body style wise median horsepower for each body type. Now we get a clear understanding that median for hardtop is comparatively high compared to all the other categories. So we can say in general, hardtop has higher horsepower compared to other body types. But if we look at the overall distribution with respect to box plot, we can see that there are some cars in other categories as well which have higher horsepower, right? This information was not conveyed with the bar plot, but since we have the understanding of the distribution and the outliers in our data, we are able to identify that there are some cars with other body type as well which will have higher horsepower compared to hardtop. Also, by comparing the distributions, we can see even though convertible has higher median value, which is shown here, their distribution is more towards the lower side. As we can see, the median is quite closer to the first quartile. And if we see sedan, so there the median was comparatively low if we compare to convertible, but their median is closer towards the higher quartile, which is Q3. So this represents even though sedan cars have low median, horsepower in general will be more towards the upper side. We can observe the same with hardtop as well, where the median was quite high, but that's because some of the cars have very high horsepower in hardtop. So this represents the 25%, this represents remaining 25%. This small chunk will represent 25%, and this range will represent 25% as well, right? This is how box plot provides more insights on our data compared to a bar plot. Now let's discuss about the distribution plot. Distribution plot works quite similar to how a box plot works, but it plots the density of our distribution. So here I have the continuous variable price, and I'm plotting a distribution plot which tells me how frequently a certain price value is coming up in my data. So here I can see that my distribution is mostly within this range, which is from 0 to 25,000, somewhere around here, right? This tells me that most of the cars in my dataset falls within this range where where at this point the most number of cars are coming up. This is somewhere around 7,500. So most of my cars are around this area. And we saw the same with box plot as well. When we plotted a box plot for price, we saw that most of the cars are within this range, 7,500 to 17,000. So this distribution plot tells us how the data is distributed across different values of price. With this, we can understand that most of our data is centered around this particular range. Now this is the distribution plot for horsepower. Again, we can see most of our cars have horsepower within this range, right? Most of our data lies within this range. So this distribution plot tells us about the density of a certain continuous variable, how price is distributed across different cars. The more number of cars coming up with horsepower within this range, the more this curve will go towards the higher side. We also saw some of the outliers with our data when we talked about horsepower box plot. We saw that there are 4 cars which do not fall within the whiskers of the box plot. Hence, we can see here as well, there is a small spike around the edge which represents that there are some outliers which are exceeding the general trend, which is this one. Most of our data is around this curve only, but there is some small number of cars who do not fall within this curve. Now let's talk about histogram. So histogram also represents the same set of information that we saw with distribution plot. While distribution plot gives us the density of certain continuous variable, histogram tells us about the frequency of a certain continuous variable. So this bar represents how many cars do we have with 60 horsepower. So this is count of cars. So this, if you see, it will follow the same or quite similar trend of what we saw for horsepower distribution plot. There is a curve like this, and if we try to imitate the same curve here, it will look something like this, right? It is in the same lines that we saw with distribution as well, just this is giving us the counts. Now this here is the Voilen plot. Basically, Voilen plot combines the functionalities of two plots, that is box plot and the distribution plot. So if you see in the middle around this area, this represents the box or IQR, while this value and this value represents the upper and lower whiskers of our data. So instead of looking at box plots and distribution plots separately, we can have the understanding of both of them with just using a Voilen plot. This This curve represents the distribution that we already saw here. For price, we have this distribution. This is the same thing represented with this curve in the Voilen plot, and this small dot in the middle represents the median price. So this is how Voilen plot combines the functionalities of both box plot and distribution plot to give us more of a deeper insight around our data. We can also plot this Voilen plot for different categories at the same time and compare them with the continuous variable. Here we are comparing the prices. So here we can see the median values for all these categories or median prices for all these car types or body types. We can easily compare and see that the median is comparatively higher for hardtop, but the data is quite distributed. Like the spread of data is quite high, while the spread of data for hard hatchback is comparatively very small. Same case with wagon, where the spread is not too far apart, but there are some outliers with wagon as well. So this small distribution represents some of our outliers. For hatchback, we have least number of outliers, which we can confirm by looking at this graph as well. It is mostly normally distributed data, and there are two outliers here. Finally, let's discuss about heat map. Heat map is also called correlation map. Now, what heat map do is it helps us to understand the relationship between each and every continuous variable in our data. As we can see with this heat map, we are trying to establish relationship across all the continuous variables that are engine size, curb weight, mileage, horsepower, and price of the car. Now let's understand what these colors and values represent. So these values here represents the Pearson correlation. So some Pearson correlation will give us one value which will be in the range of -1 to 1, depicting a negative and a positive correlation, where 1 represents a positive correlation of 100% and -1 represents a negative correlation of 100%. Now let's understand how continuous variables in the data are correlated with each other. So let's first see engine size with engine size. It has a correlation of 1 because we are comparing the same variable with each other. Now let's compare engine size and curve weight. So this has given us 0.85, which is a positive value, so which depicts as the engine size increases, the weight of the car will also increase by a factor of 85%. This is something we can also assume in real life scenario as well. If we increase the size of the engine, obviously the weight of the car will also increase. Now let's check the correlation between engine size and the miles per gallon, which is our mileage. So we can see as the engine size increases, the mileage of car actually reduces. We saw the same observation with scatter plot as well, but this gives us a number to that correlation, that if we increase the engine size, it will reduce the mileage by a factor of 67%. Okay. Similarly, engine size and horsepower has a positive correlation, which depicts as the engine size increases, the power of the car will also increase. And as the engine size increases, the price of car will also increase. Similarly, we can identify relationship between each and every variable with each other. We can also see the relationship between horsepower and the weight of the car. So there is a positive relationship of 0.75. This is all regarding the visualizations. Now, let's have a recap of what we have covered in this session. We started by discussing what visualizations are. We saw what all different advantages visualizations offer when it comes to data analysis. Then we saw the different types of data we can visualize, that are qualitative and quantitative. Qualitative data also has two subtypes, that is nominal and ordinal. And quantitative data will also have two subtypes, which are continuous and discrete. Then we talked about different types of visualization. First, we talked about scatter plot, which helps us to understand the relationship between two variables. Then we talked about line plots, which helps us to understand the trends with respect to time or with respect to continuous variables. Then we talked about bar plots, which helps us to compare the quantities with respect to given categories. Then we moved on to pie charts, which helps us to understand the proportion of our data across different categories. Then we talked about count plots, which helps us to understand the counts per category in our data. It helps us to understand the frequency of a certain category in our data. Then we talked about the distribution plot, which also helps us to understand the density or the frequency of a certain data point across our data. It helps us to understand the distribution of a certain variable in our data. Mostly we do the distribution plot on continuous variables, where it helps us to understand the frequency of each observation across our data set. Then we talked about histograms, which also helps us to understand the distribution or the frequency of a given data point across our data, but it represents the data point in terms of bars. Then we discussed about the Boylan plot. Boylan plot helps us to combine the functionalities of box plot and distribution plot, and we can understand the data much better by comparing the volume plots of different categories across our data. Then finally, we discussed about heat maps, which helps us to understand the correlations across our variables in the data. So in the upcoming lectures, we'll practice all of these visualizations with the help of Python libraries like Matplotlib and Seaborn. Till then, keep practicing. Thank you for joining this session. We'll see you in the next one.